Hey guys, Andrew here, and Mr. T. This is the Rock Cycle project. I think that's what it's called, right? I'm making a video for this, as I did for the Your Life in Numbers, because this is my format, and I get views on YouTube for Godzilla Freak. You know, I want to get 10k views on the channel in total. Help him out here, so yeah. Just gonna upload the thing. It's also really easy to make a video because I don't have to write things, I can just say it. So yeah, let's start the video. So we're gonna be talking about the rock cycle, and the rock cycle is, well, you know this, but we have to say it anyways, right? Yeah, okay. So the rock cycle is about how rocks change into other kinds of rocks, and it's like a cycle where it keeps going forever. The rocks just keep changing into different rocks. So, where should we start? Let's start with igneous rocks, okay? So, here's my picture of the rock cycle real quick. It's not very good, but I think it's viewable. So let's zoom into igneous rock. Okay. So, igneous rock is a type of rock that is formed when magma cools down, okay? So, let's just head back a little bit in the rock cycle to the magma. And as you can see, when the magma cools, it turns into the igneous rock, okay? And then, igneous rock, let's say some examples of igneous rock, okay? Here are some examples of igneous rock: basalt, obsidian, and granite. Igneous rocks have subcategories known as extrusive igneous rocks and intrusive igneous rocks. Now these rocks are, well, different. And the way they're different is how they're formed, or more importantly here, in this case, where they are formed. Basalt and obsidians are examples of extrusive igneous rock. I don't know why my speech is so bad. Probably have to edit that. So extrusive igneous rocks, well, it means that they're extrusive. Okay, that was terrible. This means that they are formed outside of the Earth mantle, on the outer crust layers of the Earth. Basically, they come out of volcanoes and then they turn into rocks because, the Earth crust is a lot cooler than the mantle. There's also intrusive igneous rocks that form in the upper mantle areas where it's cooler, or in specific places underground where it's cool enough for the rocks to, well, cool down and turn into igneous rock, or should I say the magma. So it's basically deeper in the ground, whereas extrusive is come out of volcanoes. Next type of rock here, well, let's go through the cycle. The next wait, there's more to talk about igneous rock still. I'll probably cut some of that out. Let's see, layers. So igneous rocks can be found in the higher areas of the mantle or the Earth's crust, underground, or on the Earth's crust surface, and they're formed in the mantle. Or like the lower crust areas, that is possible too, where it's really hot, but only in the deepest part. Maybe even that would be the upper mantle, I'm not sure. When it comes to geographical locations, I'm pretty sure you can find igneous rock everywhere. But people don't ask about this stuff. So I'm just going to say stuff I know, okay? So igneous rocks, from what I found, can be found in northern Canada. They can be found in Hawaii. The reason I pick Hawaii is because there's volcanoes there, and volcanoes make igneous rocks from extrusive ones, at least. So there's one. And Calgary, because I live in Calgary and I know there's igneous rocks. Oh, even if they're not native, I can still find them here. So confirmation, right? Self-confirmation. What makes up igneous rock? This is another question I have to answer. Igneous rocks are made up of things like quartz, feldspar, micas, potassium, magnesium, and more. There are many different things that can make up igneous rocks based on what is in the magma. So let's move through the rock cycle now. So igneous rocks, where should we go from here? I guess we'll go in the most linear path of the rock cycle. I guess you would call it the shortest path on the rock cycle. Let's move on to heat and pressure. Okay, so heat and pressure is when a type of rock, in this case our igneous rock, gets compressed down with heat and, well, more importantly, pressure in the really low crust and, for the most part, the mantle of the earth. And you know how, like, say you're underwater, you feel heavier because there's so much pressure? Well, the entire earth has that effect. So if you go lower into like the really low crust or the mantle, well, that pressure is really strong, and even rocks break down at that low of a level. So at that point, igneous rocks can actually like compress and change. And that changing process, they like crystallize and did I just say like whatever? They like crystallize and compress and they transform into a different type of rock, which transitions us to the next type of rock, wherever that, oh, there it is. The next type of rock, which is metamorphic rock. After heat and pressure, a rock will transform, well, it can transform into a different kind of rock, in this case metamorphic rock. Well, it will always be metamorphic rock, at least for the most part, because you know that's how it works. And metamorphic rocks have completely different structure to igneous rocks. For layers that they can be found in the mantle, or like the crust and mantle, upper crust, like higher upper mantle, middle mantle. You can find them in all those places, and they form around in the mantle where it's you can compress it, but not in areas where it's too hot. In that case, they just melt into magma. Moving on, they can be found in geographic locations like Brazil, India, and the Himalaya mountains. I know, really random, but I'm pretty sure you can find them everywhere, so these should be accurate, okay? Going on to what makes up metamorphic rocks, they can be made up of things like garnet, muscovite, chlorite, calcite, or talc. And some of these are also found in igneous rocks, while others are not, and are exclusive to metamorphic rocks. And maybe also sedimentary rocks, I think. But yeah, those are things that can be part of metamorphic rocks in that process where it transforms. Okay, moving on in the cycle, we get to weathering and erosion. Right here, as you can see, this is like a rain cloud with rain. That represents the weathering and erosion. And basically, this process is where rocks get weathered down and they break down, and things happen to the rocks, and they can get like swooped away by water and streams and break down more. Then that transitions us over to the next one, which is sediments. These rocks, after they're broken down, they can transform into these things called sediments. Sediments are basically pieces of rock mixed in with like organic matter and other things that just like mix together, and they're these little pieces of minerals, rocks, organic matter, and fossils and stuff. Which brings us to the next point. When sediments collect a lot, they connect together and they start fusing, they can compact and cement. So the way this happens, if say like something falls on them, there's some weight, it like pushes it down and it compresses itself. Or if something's sticky, for example, or I don't know, like the weather or water. I guess water with certain things would work. Or like fuse it together, these little bits and pieces of things, and they can transform to what is known as a sedimentary rock or multiple sedimentary rocks. Sedimentary rocks usually have many layers to them. My picture here doesn't really represent it too well, but that is how a sedimentary rock could look, at least in cartoon form, because the colors won't be that bright, alright? But it will look something like what I drew here with the purple. That is something that exists. At least something similar to it would exist. And yeah, and like let's come up with some examples. Well, not come up. I already have them down here. Okay, some examples of sedimentary rocks are flint, coal, and sandstone. So let's start with the coal because this one's the one I found most interesting. Coal is a sedimentary rock, and it is known as an organic sedimentary rock. I know, right? Organic. Like, what does that mean? Well, you should know what organic means because you're the teacher, but basically, yeah, you know this, but I have to say it. An organic sedimentary rock is a sedimentary rock made up of organic materials. Okay, that doesn't really explain much. Like, for example, living things, leaves and fossils, and well, fossils aren't living, but you know, they were living. Like leaves and stuff, and trees. Yeah, trees, for the most part, the wood that's made of carbon, and that can break down and mix in with other things. And coal is a very good example of this, where organic things come together and they turn into a rock. And you know, we use coal for fossil fuels. That's why they're called fossil fuels. What really interests me was that these are actually sedimentary rocks rather than igneous or metamorphic rocks. Probably because, you know, heat and stuff will like destroy it, maybe. I'm not sure. But yeah, coals and sedimentary rock, that really interests me. Now let's move on to flint. Flint is a chemical sedimentary rock. And let me just read the definition here that's the first result when you search up on Google. Alright? This definition feels like someone really wanted to use some long words, right? Let me just read this. Chemical sedimentary rock formed when mineral constituents in solution become supersaturated and inorganically precipitate. Like, what kind of thing is that? Let me take a screenshot of this and put it in the video real quick. Cause, what? Why did you? Okay, let me pick out some of the questionable word choices. Constituents in solution become supersaturated and inorganically precipitate. Why? Why do you use those words? Okay, I'm going on a tangent now. I don't want this video to be too long, even though it already is. But from what I can resolve, I guess would be the word to use here. See, I'm starting to use complex words now. I should stop. So from what I can see, this means that like mineral parts in a solution where they're mixed together, like they get saturated to the point where the water can no longer contain them, and then like they just turn into rocks. I remember in what grade was it? Was it like grade 5 or something? We did rock crystals, and that's basically what this is from what I can see in this definition. So yeah, flint I guess is a crystal, like a rock crystal. I don't know, close enough, right? So flint's an example. And then the last example I have is sandstone, which is a clastic sedimentary rock. And from what I can find, clastic is just like, yeah, they just like bury together and they compact in cement. And basically when sediment just naturally forms together, it's not special. It's like the least special one. It's like paramecia devil fruits in One Piece. I know you probably have no idea what that means, but it's the not special kid, you know? It's like, okay, so if you're like crystallized, you become a chemical one. If you're organic and you're like a fossil fuel or something, you become coal. Not coal. You become an organic one. If you're anything else, you're a clastic one. These are ones where it just comes together. It's not really specifically organic. At least that's from what I can see. So there are some examples of sedimentary rocks. Next, we have to include layers that sedimentary rocks are found. Well, they can be found on the crust of the earth for the most part. For the most part, it will also be on the higher areas of the crust of the earth. Except chemical ones, I guess they can form like caves and stuff too. But I'm just thinking about that. Like, that's just a theory I have that they could. They might not. They don't exactly form in the mantle because the sediments will just like burn up. So, yeah, they're formed on the crust. And geographical locations, I know they can be found in the Mojave Desert. I know, super specific. They can be found in California and also Kansas. If Mojave Desert happens to be in one of these places, I guess I'll just choose Tangshan because I've lived there and I know they're sedimentary rocks. So, yeah, there's your 3 geographical locations there. I'm pretty sure, again, they can be found everywhere. But, gotta be concise. Is that the word to use? I don't know. That definition messed me up. So, what makes up sedimentary rocks? Well, sedimentary rocks are one of those things that can be made up of a lot of things because it's just stuff mixing together. Like, I can freaking take a piece of plastic, throw it out the window, like broken down. I can rip the plastic apart, and it might wind up in a sedimentary rock in a million years down the line. That's how they are, right? So basically anything can be there, but here are some common parts. So silicon, carbonate, clay, phosphate, and Permian. So I've heard of these things before. I don't know exactly what they are, except like clay and silicon. I know what those are. Silicon is just so commonly found that, not really commonly found, so commonly, said that you just end up knowing what it is. Carbonate, carbon's in the word, so I think I can infer stuff with that. Clay, yeah, clay, I've done art. I know what clay is. Yeah, I'm pretty sure that it's part of basically every school's art. Almost all the schools will have clay in their art. At least the ones here in Canada. Yeah. At least in Calgary, okay? I can't confirm anywhere else. But in Calgary and Panorama, yeah, they have that. Permian, these are just some decently common ones I found on the internet. There's a lot, as I just said, you can just chuck some random stuff in the atmosphere and you can turn it into a sedimentary rock as time goes by. So then let's get back to igneous rock because, it's a cycle. There's 3 types of rock. Now we're going to go back to igneous rock. When sedimentary rock goes through heat and melting in the earth mantle, if it goes in the mantle, there's a lot of heat and it can melt down into magma right through this process, as you can see here, magma, and it then cools again. It can stay magma for a long time. It might wind up in the cord one of these days, but that wouldn't be part of the rock cycle anymore, would it? Just be stuck there. But I don't think that happens very often though. So then that's just a theory, but that's not even part of the assignment, so I guess I can be wrong with that. Next, the magma, if it goes to a place where it can cool down, I've already went over this, it can cool into an igneous rock. Now, you might be thinking the video is over. Well, you're probably not, because you assigned this, so you know all the things that are going to be in it already. This is really pointless. Well, wait, I'm presenting the class now. I completely forgot about that part. Whatever, it's fine. So, yeah. I've been exclusively talking to Mr. D this entire time. Sorry, classmates, feel bad for ya. So, yeah, it can become igneous rock, but that was only one of the ways the rock cycle can play out. The igneous rock might not go to heat and pressure and become a metamorphic rock. It might have went through weathering and erosion and then became a sedimentary rock. Or it might have went to heat and melting and turned into a different kind of igneous rock. And that metamorphic rock, it might not have just weathered, it might have went to heat and melting and became an igneous rock. Or it could have went back in the cycle to heat and pressure and became a different kind of metamorphic rock, like a double metamorphic rock. Okay, this is just bad. On that sedimentary rock, you know, it might not have melted and into magma and turned into an igneous rock. It could have turned into sediments through weathering and erosion, and became a different kind of sedimentary rock that's been mixed with different things. It might become a different type of sedimentary rock, or it might went up through the cycle into heat and pressure. And then it might have became a metamorphic rock. And the metamorphic rock, who knows what would happen there? These rocks can rampantly go through the cycle which way they want over millions of years. Okay, this last part, it's so bad, but here's a full view of the rock cycle. I don't know how long it's going to take to edit this video. Hopefully not too long. Here's a full view of the rock cycle picture I made on Photoshop. I did the whole thing myself. I didn't take anything from anything. Okay, I know the art isn't even that good. The writing, it's really funny. I didn't write it in Photoshop. I opened on the notepad, wrote the thing, then took a screenshot and put it in. I know, genius, right? It's because this Photoshop is broken, kind of. So whenever I type something, it just asks if I want to save it. If I save it, it closes it. If I don't save it, it closes it without saving. So that kind of sucks there, but that's going to be all for today, guys. Take care of you all. Goodbye. Anticlimactic ending, I know. I have to redo the outro now. Okay. That's going to be all for today, guys. Take care, y'all. Goodbye.